Hello again. Um, Nice to talk to you again. We're gonna do some algebra, specifically how to add and subtract rational expressions. Um, let's review what a rational expression is first. So a rational expression is usually just a polynomial over a polynomial. So x plus y, that's a polynomial, over x minus y, another polynomial. And we're going to add or subtract something like that with another fraction that is similar to it. I'll just write that because I can't think of anything more creative. So we're either going to add these two types of fractions or subtract them. Now, to do that, we're just using a very basic adding, subtracting fraction rule, which we learned in third, fourth grade, which is if you have two fractions with the same denominator, then you can add or subtract them. So this will become a plus or minus b over c. So if you got the same denominator, it's really easy, quick and easy. If they're not the same denominator, well, then you got to get a common denominator, right? So in this case, I can multiply the top and the bottom by d, and the top and the bottom of the second one by c to get the common denominator, and then I can add. That is not the only way to get the common denominator from unlike denominators, because it's possible c is a factor of d, or d is a factor of c. So I may not have to actually multiply c with d to get the common denominator, and you'll see in the examples that we're going to do that you don't have to do that all the time. Okay, so let's actually do this with rational expressions now. So here's my example number 1, starting off with a very simple one. 1 over x plus 1 plus 1 over x minus 1. Okay, these denominators are not the same, so I do have to find the common denominator on my own. X plus 1 is also not a factor of x minus 1, or vice versa. So my common denominator will be the product of x plus 1 and x minus 1, which means I will have to multiply the top and the bottom of the first fraction by x minus 1. There you go. And then I also have to multiply the second fraction by something different, x plus 1 over x plus 1. And now I may add the fractions. That's the sum of the two numerators, and this is my common denominator. These cancel each other, so I get 2x in the top, and I'll go ahead and write that denominator as x squared minus 1, and there you go. Okay, nothing too fancy about that. Here we go with the second example. 6. Okay, I put this one in here because it's got a little twist in it, sort of figuratively and literally a twist. But it's a nice twist because it's something you can deal with quite easily. So at first glance, it looks like the two denominators are not the same, in the same way that x plus 1 and x minus 1 were not the same. And so if you're not thinking carefully enough, you might think, oh, I got to multiply these two denominators with each other, and that's my least common denominator, but that's not true. You'll notice that 2x minus 3y and 3y minus 2x have the terms switched, the terms order switched, but it's still a minus. So in other words, the form of the two denominators is, and I'll write that down here, it's a minus b and b minus a. A minus b and b minus a. And that's important because if I take a negative out of a minus b, factor it out like a GCF, the leftover is negative a plus b, which is also known as b minus a. So this a minus b is actually negative b minus a, which is really similar to b minus a. It's just the negative of b minus a. So I can do that over here. Take a negative out, and this becomes 3y minus 2x. Almost the same denominator as this, right? So all I have to do to get a common denominator is multiply this first fraction by negative 1 over negative, negative 1 over negative 1. And now I can subtract the fractions, getting negative 9 in the top and 3y minus 2x in the bottom. Okay, so what looked like, a medium amount of work to do actually turned out to be not so much work. Okay, moving on to my third example. We've got 1 over x minus 2y minus this more ugly looking fraction. Okay, that second fraction does not look nice at all. It's got higher exponents, it's got weird coefficients, and so again it might look like, oh no, I got to multiply this binomial with that binomial. But no, if you look at that denominator, that's a cube, and 8y cubed is also a cube. So this is a difference of cubes, And I'll write down here a little reminder of how difference of cubes factors, because it does have a pattern to it. Okay, that's how that factors. So I'm going to go ahead and factor that so you can see what the factors actually are. Okay, there we go. And you'll see that one of the factors of x cubed minus 8y cubed is x minus 2y. So that means the least common denominator is this. And to get the common denominator showing in this fraction, all I have to do is multiply this fraction by the other factor, the missing factor, over itself. And so here I go, doing that. And I'm going to go ahead and combine it into one fraction. So this is the numerator of the first fraction, and I'm subtracting the numerator of the second fraction, but the second fraction is, the numerator is a binomial. So when I subtract the binomial, I want to subtract the entire binomial. So I will put that in parentheses so I don't make any mistakes. And the denominator, I guess I'll leave it in factored form. And then I'll distribute this negative in the top, and maybe there's something I can, I can combine some like terms. And yeah, it looks like I can cancel out these x squareds and these 4 y squareds, and I'm left with 2y over x minus 2y. Okay, there we go. Okay, I've got one more. Okay, this one's different because the denominators are trinomials. And I'm really hoping that I don't have to multiply the two trinomials with each other to get the least common denominator. The only way I can know for sure if I have to do that or don't have to do that is factor the two denominators. And thankfully these are easy to factor. Okay, so what does this tell me? This tells me that my least common denominator, I'll write it over here, has to have an x minus 5, which both of them already have, that's good. They have to have an x plus 2. That one has it, that one doesn't. And it has to have an x minus 1, which this one has and that one doesn't. Okay, so now I know each of the denominators is only lacking one factor. This one's lacking the x minus 1, this one's lacking the x plus 2. So I will multiply this fraction by x minus 1 over x minus 1. I will have to FOIL this up top, but that's not so bad. And then in the second fraction, I'll have to multiply the top and the bottom by x plus 2. And that's just going to get multiplied with the 16, so that's not that bad either. And my LCD will be x minus 5, x plus 2, x minus 1. Okay, foiling in the top. Let's see what happens here. I get 3x squared, 10x, minus 16x, that's minus 6x. And then negative 13 minus 32 is minus 45. And I'm feeling like I made a mistake, so I'm going to review my work, which is something everybody should do. Okay, first check the factoring. Factoring is correct. Factoring is correct here too. Did I FOIL correctly? 3x squared minus 3x plus 13x minus 13, that was FOILed correctly. 16x minus 32, that looks right. x minus 16x. Okay, that looks right. I'm going to check here if it's possible to factor the top now that the terms have been combined. And maybe when I factor the top, something will cancel. Right. Ah, yeah, that does factor. There we go. So it gets even better. 3x plus 9 over x plus 2, x minus 1, and I'm sure I can't do anything more than that. And that is the last one. So remember to get your least common denominator. You might have to multiply both denominators together. You may not. Maybe you only have to multiply one of them by -1 to make it the same as the other. Maybe one of the denominators is a factor of the other denominator. Or maybe the two denominators share at least one common factor. So look out for all of those things. Thanks for watching K109 Math, and we'll see you later.